Hi there, this is the Gesualdi Spy Association of Mathematical Americans. We are excited to announce that out of all the bright minds out there, we've chosen you to come and join our prestigious group. Congratulations! Unfortunately, there is no more time to celebrate, because Control just lost the GPS tracking for two of our spy ships, so they need us to utilize the power of related rates in order to help them calculate the rate of change of the distance between the ships. Let me show you how it's done. All we know is that two of our spy ships left from base G. The first is traveling north at 240 meters per second, and the second is traveling 70 meters per second east. We also know that the first aircraft is 50,000 meters north from base, and the second ship is 480,000 meters east. First, when solving related rates, we need to find the equation that relates the quantities given in the problem. In this case, we are going to use the Pythagorean theorem because a right triangle is formed between the two ships and the base, so the relationship is formed by the equation a squared plus b squared equals c squared. The next step is to take the derivative with respect to the time for both sides of the equation. So a squared plus b squared equals c squared is going to turn into 2x dx dt plus 2y dy dt equals 2z dz dt. However, we are still missing the value of z, so before we can plug in the given variables and solve for dz dt, we must first calculate the distance between the two ships, which is the value of z. So let's get to it. Well, there it is. The rate of change between the two ships is 246 meters per second. Don't you just love math? We wouldn't have saved the day without it. I hope you learned a lot from the experience, and once again, welcome to GSAMA.
Created using Powtoon.